Well, good morning. My name is Dwayne Brown from NASA Headquarters, Office of Communications, and we are live at the Johns Hopkins Applied Physics Laboratory in Lowell, Maryland, where on July 14th, 2015, the world will witness one of humanity's most historic moments in space exploration. This morning, you will hear about the preparations, expectations, and plans for NASA's New Horizons historic flyby of Pluto. We'll have brief remarks and then open it up for questions from our attending media. We also will have questions from social media. And of course, the worldwide audience join the conversation via Twitter, Facebook, and other social media platforms talking about the July 14th flyby. And send in your questions at #AskNASA. And of course, all this information you will hear today and over the next several days, weeks, and months will be available online at www.nasa.gov/New Horizons. Before we get started, let me introduce you to our panelists. First up, John Grunsfeld, 5-time Space Shuttle flown astronaut and Associate Administrator for NASA's Science Mission Directorate, and let me add that New Horizons is one of almost 100 missions under his portfolio. Alan Stern, Principal Investigator, New Horizons from Southwest Research Institute in Boulder, Colorado. Glenn Fountain, Project Manager for the mission at Johns Hopkins Applied Physics Laboratory. And Kathy Olkin, Deputy Project Scientist, also at the Southwest Research Institute in Boulder. And with that, I'll turn it over to John.
Thank you very much, Dwayne. Well, it really is incredibly exciting to be here on the eve of our Pluto flyby. In fact, we're 21 hours, 17 minutes, and 38 seconds away, but who's counting? Our mission at NASA is to innovate, explore, discover, and inspire. And I think the New Horizons spacecraft in every aspect, as an innovative spacecraft, as a mission that's exploring an entirely new realm of our solar system, and one that already has produced a number of discoveries, and I'm absolutely positive will create enormous buzz in the scientific world, as well as inspiring a nation and a world, really characterizes the essence of what we do at NASA. I'm very excited about this mission for a number of reasons, one of which is that it is, in fact, opening up a new realm of exploration, not only for Pluto and Pluto's moons, but where it goes afterwards. So we're looking forward to lots of discoveries, lots of inspiration. It's just a buzz here at the Johns Hopkins Applied Physics Lab, just outside of Baltimore, with lots of scientists, lots of engineers. And really what this mission is all about is the extraordinary things that NASA can do as a team with our partners, with taxpayer investment, to produce wonderful science, science that answers questions about where we come from, where we're going, and in essence, trying to answer even a bigger question, which is, are we alone in the universe? The Pluto system is a fossil remnant of the beginnings of our solar system, and we're going to hear more about that. But really, we're going to learn about where we're coming from in terms of the building blocks of the solar system. And so with that, I'd like to turn it over to our principal investigator, Alan Stern.
Thank you, John. Good morning, everybody. It sounds like science fiction, but it's not. Tomorrow morning, a United States spacecraft will fly by the Pluto system and make history. I think this is a great example of a great society and a great nation and what great nations do. And I have to tell you, the data that we're going to produce, in fact, the data that we're already producing, is a gift for the ages to all mankind. The science that we've already made, and if we can show the approach video, is already mouthwatering. The Pluto system is enchanting in its strangeness, its alien beauty. It's showing us tremendous diversity between the two planets in the system and their moons. We are already seeing a complex and nuanced surfaces that tell us of a history for these two bodies that is probably beyond our wildest dreams on the science team. Pluto has not disappointed. I want to tell you a few things that are new, that are just being released now, that we have learned in the last 48 hours. We have discovered that we are already detecting nitrogen escaping from Pluto's atmosphere. And the important part of that is that it was discovered 5 days ago, much farther from Pluto than we anticipated. This may mean that Pluto's escape rate is higher than models had shown, or it may mean that the transport mechanism is different than what we anticipated. We've also discovered that the putative polar cap on Pluto's north pole is in fact just that. We now have compositional spectroscopy that shows methane ice and nitrogen ice there. So we now fingerprint it. It is an icy polar cap after all. Our ultraviolet instrument ALICE is seeing the surfaces of both Pluto and Charon, and Dr. Randy Gladstone, who leads our atmospheres team, will have more to say about that in the coming day or so. And we've discovered that Pluto's a little bit larger than we anticipated. We now have good measurements of its diameter and its radius. Its radius is 1,185 kilometers, plus or minus 10. That settles the debate about the largest object in the Kuiper Belt. It also has important scientific implications. Because it's larger, and we've known its mass very precisely for a long time, that means it's a little less dense, which will raise the fraction of ice in the interior that modelers will need to compensate the rock in the interior. It also means, because it's larger, that the troposphere, the lowest layer in the atmosphere, is shallower than some models had predicted. The larger radius has other implications as well, and you'll be hearing about those over the coming days. I'm looking forward to what we're going to be doing. You know, in just a space of 24 hours, our resolution on the planet is going to jump from around 15 kilometers per pixel to less than 100 meters per pixel. That's more than 2 orders of magnitude in the coming day. So fasten your seatbelts. New Horizons has arrived at the Pluto system. Glenn?
Thanks, Alan. Well, I've said for a long time that the engineers would be having the excitement on launch and some of the travel through the solar system. And I'll tell you a little bit about that at some of our last challenges. But it's now time for the scientists to give us the excitement. And I think you can just, as you just heard from Alan, they're not going to disappoint. So I'd like to put up a graphic for a moment just to remind you that it has been a challenging mission. Some of you have seen this graphic before. It's a photograph of the spacecraft as it was being finally prepared for launch back in 2006. And you can get the sense of it. It's like a concert grand piano with a big salad bowl on top. The salad bowl being our 2.1 meter diameter antenna that allows us to communicate back. And we have had this system operating for 9.5 years, and all the systems on board, and there are redundant systems on board, it's all working. All working as it's planned to operate. And as you heard, the instruments are providing wonderful data. So I'll talk about one of the challenges in this last stage of the mission. And that is how we navigate to get to the right point so we can take all the data that you're going to hear about over the next couple of days. And so this next graphic kind of tells you the tale of this. So if I could have that. So what you see here is a golfer sitting in New York making a hole-in-one by lofting a golf ball across the country and putting it in the cup in LA. That's the kind of precision that this team has done, getting the spacecraft to where we need to go at Pluto, across the 3 billion miles that we have just traveled. So in the next chart, we'll give you a little bit more. This is a little animation to kind of give you that last piece. So right here, you're seeing the spacecraft along its trajectory, and it's about to go by. You see Pluto and Charon, and there it goes, And we have to go through what we call the keyhole, that little green spot that you see there. And that is the distance we have to be precisely to actually take the data that you are hearing about from Alan and from Kathy and from others later. And we have done that so well that I don't even believe it. And the reason is we have been discussing for a very long time exactly what the radial distance of Pluto is from the sun. We've only learned about Pluto since 1930. We've only seen a part of one orbit. It takes 248 years to take one orbit around the sun. And so there was a great deal of uncertainty about exactly how far the planet was, Pluto was, from the sun. We know where the spacecraft is, but where is the spacecraft with respect to the sun? We have navigators that help us make those final determinations. And because the LORRI instrument, the one that's taken a lot of these images, was able to detect some of the satellites, namely NICs, earlier than we thought, we were able to nail that position very, very precisely. And we have had discussions about that in the last few days. And the next graphic will show you this. So we're 7,750 miles from the Pluto surface. And the green box that you see there is the box that we actually have to pass the spacecraft through. And the yellow box is the knowledge we want to have. So the green box is 60 by 90 miles. After going 3 billion miles, we have to hit this 60 by 90 mile box, and we're actually almost to the center of it. And so we decided the yellow box is what the spacecraft thinks that the spacecraft is going through the center of that yellow box. And we're actually going a little bit off of it, but anything inside that yellow box means that we get all the data. So we are good to go for this last bit of the trip. Right now, at the start of this press conference, the spacecraft was 658,000 miles from Pluto. So after 3 billion miles and a little over, we're just that far away. And in the next graphic, just to remind you, this is the path through it. At 7:50 tomorrow morning, we'll be at closest approach, passing through that ring plane. We'll go on through, and then later that day, after we've traveled another 420-some thousand miles, the spacecraft will turn back. So 7:50 tomorrow morning, you will celebrate we're there. And then at 9 o'clock tomorrow evening, you'll hear the signal that was sent at around 4:20 in the afternoon at the speed of light actually getting back to the Earth. So we'll all have a real celebration at that time. And so that's as much excitement as I can provide you. So I'm going to turn it over to Kathy.
Hi. I'm so excited to be here and talk to you about the Pluto system. I want to show you an image that we have of Pluto and Charon. And observations like these, stunning images of Pluto and Charon, are going to help us sample the diversity and the science of these complex worlds. We're going to be looking at the geology and the composition. We're going to be studying the atmosphere of Pluto. Using data like these and other observations, we're going to be looking at the temperature of locations on Pluto, imaging the small satellites of Pluto, looking at the composition of those small satellites. In addition, we're going to be making stereo maps so that we can see how tall the mountains are and how low the valleys are. All of this will be accomplished with our comprehensive payload. We have 7 instruments on board the spacecraft. You can see them here. And they sample the Pluto system with everything we've got, from the ultraviolet to the visible, the infrared. We probe it with radio science. We look at the energetic particles in the area using PEPSI and SWAP. We also are looking at the dust in the outer solar system using the student dust counter. All of this science was designed to be complementary and comprehensive by this 7-instrument payload. So the instruments are fixed on the body of the spacecraft. So if we want to take an image of Pluto, we have to turn to point the cameras at Pluto. And so I want to show you the dance of the spacecraft as it goes through the Pluto system. There's a simulation I'd like to bring up now. This is the simulation of the sequence of commands that will be taking place over the 10 hours around closest approach. The spacecraft is in the foreground. The lines going from the spacecraft to the Pluto system show you what the instruments are looking at. And then in the small inset box in the upper right, you can see the targets as they go through the field of view of the instruments. Down in the lower left, you can see the closest approach distance and the time to closest approach. As the spacecraft is doing its dance, you can see all the instruments are taking their turns and looking at the targets in the Pluto system. We're looking at Charon, and now we're looking at Pluto. And this is how we're going to get the best science return that we can. And this will all be happening tomorrow. Currently, the spacecraft is doing a similar dance. It's just a different set of commands. So as we're getting closer to the Pluto system, you can see that Pluto and Charon are getting larger in the fields of view of the targets. Now we're near closest approach. Right here, we're taking data that if you could transport Central Park to Pluto, you would be able to identify the ponds in Central Park. That's the kind of resolution we'll be getting with those strip of observations by the high-resolution camera as we fly through closest approach. Then, after closest approach, we'll be watching the sun set behind and rise above Pluto. We'll be doing the same thing at Charon to understand and search to see if there's any remnant of an atmosphere around Pluto's large moon, Charon. And then, as we get further away from the system, we're going to look back and we're going to take images of the crescents, the lit crescents of Pluto and its moons, and we'll be searching for clouds and hazes in Pluto's atmosphere using these observations. It's going to be an exciting time tomorrow when the spacecraft is taking all of these observations as it goes through the system. Between this time now and closest approach tomorrow, the spacecraft will be taking about 150 observations. So that gives you an idea of the pace and the sequence of what will be going on. And I can't wait till we get there tomorrow.
Okay, thank you. Okay, ladies and gentlemen, before we transition into the Q&A, let me just let you guys know that this mission is going to have a lot of audibles, and we're going to need the media to be flexible. The information is going to be coming. It's going to be changing. For the media that are watching across the nation, and in fact across the world, we will have phone capability for the several press conferences for the week and next week. For further details on that, please call the newsroom at 240-228-8532. That's 240-228-8532. For the media here, we're going to start, if you want to wait for the mic and give your name and affiliation, and then, of course, we're going to go to social media, and then we'll take some more questions. These folks have to cut out of here pretty fast. They've got a meeting and have to go over to Mission Operations Control, so let's see how many questions we can get in before we have to close off here. If you can raise your hand and you get the mic, and give your name and affiliation, please.
Leo Enright with Irish Television. You've got compositional information on the pole of Pluto. Can we expect something similar for the dark pole of Charon during the week, or is that likely to be much later?
Well, first let me tell you about the kind of compositional mapping that we're doing now and what to expect. On board the spacecraft is an instrument called Ralph that has an infrared mapping spectrometer that allows us to put pixels on the planet. At the distance that we were this weekend, we were already able to distinguish the polar regions from the equatorial regions. But as we drive in so much closer, the resolution improves dramatically. Ultimately, the kind of maps that we'll make will blanket the surface with pixels about 10 kilometers across. So that's a very large number of pixels on the surface. And we'll do the same thing for Charon. And in fact, we'll get some measurements of the two intermediate-sized satellites as well, Nix and Hydra. In terms of the downlink schedule, Kathy may know a little bit better than I when we're going to get the Charon information, but we certainly have the resolution and signal-to-noise to tell what that dark region is like, how it's different from the water ice composition that we see on most of the surface. Kathy?
Yeah, so we will definitely be getting down Charon spectral information in the infrared, which is how we'll look at the composition of that dark region of Charon. And it will be coming down this week. Because the infrared mapping spectrometer takes so much data, there's so many pixels, we're bringing down selected wavelengths and sections this week so that we're not dominating the downlink. And so we will have some information, but it will not be the complete picture yet.
Can I ask a follow-up? I don't think Alan Stern will be too, or sorry, I don't think you'll be too surprised by this question. But you've suggested to the IAU a naming sequence for features on the surface of Pluto, and you've included people who've contributed to knowledge of the Pluto system. Do you expect that you will be naming a feature on Pluto after the Irish astronomer Kenneth Edgeworth? Do you imagine that will be a large feature? And if you could very briefly explain why Edgeworth would be significant.
So here's the one-on-one, here's the background. I think everybody in this room and many people in the audience know that Pluto orbits in this third zone of the solar system. Beyond the terrestrial planets and beyond the giant planets is this newly discovered region called the Kuiper Belt. Well, the Kuiper Belt got its name because a very prominent 20th century Dutch-American astronomer named Gerard Kuiper wrote prominently about this as a conjecture in the middle of the 20th century, in the 1950s. But prior to that, Kenneth Edgeworth from Ireland had also written about the same topic. He had papers in 1943 and 1949. If you go back and read them today, they're brilliant. He nailed it. He had the concept himself. And for a while, after the discovery of the cohort population that Pluto orbits with in that third zone, many planetary scientists called the region the Kuiper-Edgeworth Belt, or the Edgeworth-Kuiper Belt. But with time, we've shortened that, and Edgeworth probably doesn't get the credit he deserves. I think you have a fine idea, and we'll certainly put it in the consideration in the name bank. As you may know, we conducted an exercise this spring where we actually asked the public to suggest names, not just for scientists, but for other naming themes. And we got a tremendous public response, and that's informed us. And in the future, you'll be seeing the actual, features being named. So stay tuned.
Next question. Let's, right here. Irene?
Irene Klotz with Discovery News and Reuters. Could someone just explain a little bit about what New Horizons is going to be doing between its 4 hours after closest approach to when it's going to send the engineering signal back, and why there's going to be no insight at all among you guys as to whether it even made it through the system okay? Thanks.
Yeah, so we have really exciting observations that are very time critical and have to happen in between that closest approach and when we send the telemetry back. And specifically, it's the solar and radio science experiments. We need to fly directly behind the shadow of Pluto and Charon and be watching the sun go behind Pluto and Charon to get our understanding, improve our understanding of the atmosphere. And we'll be sending signals from the Deep Space Network also through the atmosphere to be received by the spacecraft. And those are very time critical, and those occur in that time period. And we'll be also getting very high phase, high resolution observations in that time.
And is there any nervousness at all that it's not going to get through okay, that there's going to be some little speck or unknown little moon or something?
Well, what Irene is referring to is the fact that the combination of the high speed of the New Horizons spacecraft and the exploration nature of this mission could bite us. We've taken what we think is a measured risk. We've searched for debris that may be in the system on approach. We've used our best instruments and found nothing of concern. Formally, we're able to set model limits at around 1 in 10,000 that the spacecraft would be lost due to a debris strike, but we've also been very honest that we're flying into the unknown. This is the risk you take with all kinds of exploration, and New Horizons will be out of touch for those hours around closest approach. And while I don't lose sleep over this, the fact is tomorrow evening is going to be a little bit of drama. We want to hear the spacecraft check back in. We want to look at the telemetry that's coming down and make sure that the spacecraft hasn't suffered any alarms. And until we pass that point tomorrow evening, we won't really know with certitude that we cleared the system and that there were no debris strikes. But I want to emphasize that I'm not very worried about it.
Okay, I know we've got a number of media here, so we'll go here and then here next. Go ahead.
Hi, Eric Hand with Science Magazine. Alan, can you say something more about measuring the radius of Pluto, 1185 plus or minus 10? First of all, making the measurement, is it just a matter of knowing how your camera works and tallying up the distance, or is there something more nuanced than that to making this measurement? And then secondly, you started to hint at some of the implications that it can affect the models of the troposphere and the interior. Can you say a little bit more about how having this number in hand matters? Is it just fine-tuning these models, or could there be some larger implications? Thanks.
Yeah, sure, Eric. So the way that we make these measurements is through a variety of different techniques. And we have a number of members of the science team, specifically in our geology and geophysics investigation team, who are making fits of circular annuli to the planform of the planet and determining exactly what fits best. We also have people that are using differential image techniques to find the edge and measuring the distance. Making those measurements of the diameter. And we have a third, little bit more indirect technique that relies upon some forward modeling. And we intercompare the results that we get. And we also have an anchor point, which is a really interesting story, so I want to tell you that. Pluto's size has been uncertain in the past, primarily because it has an atmosphere, and the atmosphere is dense enough that it can actually create mirages when stars are observed through occultations to set behind the planet. Kathy's actually an expert in this technique and has done many of the occultation expeditions of the last 10 years. And so we get a range of sizes for Pluto that before New Horizons range from about 1,150 kilometers in radius, twice that in diameter, up to a little bit north of 1,200. And what we found is Pluto's almost at the top of that range. But in order to anchor our technique and be certain of our numbers, there's some ground truth in the system. The moon Charon has no atmosphere, so it doesn't create those mirages. Ground-based occultations have told us that Charon's radius is 602 or 603 kilometers, period. So we took all those techniques that we're applying for Pluto on approach and applied them to Charon, and we get the right answer with all the techniques so that we, as I said, anchor our belief that the 1185 is good by testing it on Charon. And then your other question was about the implications. I think that's going to take a while to unravel. The fact that the planet is larger than expected, as I said, lowers the net density, that raises the net ice content that's inside, lowering the rock content. That has implications for things like how the binary formed. It has implications for the chemistry of the solar nebula. The implications for the atmosphere, having a shallower troposphere, are still something I think we'll be unraveling in the future. This is news that's less than a day old, when we really got to consensus that the technique had the right error bars and had the right number. I don't expect it to really change more than a few kilometers as we go forward. But we can talk to you about implications offline, but recognize that it's been a long time since we've done something like this. And I don't know how many of you were around in the Voyager days. I was not, but during that time when we were exploring brand new planets for the first time, science on the fly often proves to be wrong because we want to take our time. I think a lot of the results that we provide for you are going to try to be at the factual level rather than at the speculative level. And then as we have more time with the data and the chance to do associated modeling, we'll be able to make better interpretations. But interpretations made on the fly often have a very short half-life.
Okay, I'm going to ask your indulgence here. We've got a number of media. If you can just limit one question. We're going to believe the gentleman here, and then we're going to come over here. We're going to go to social media, and then we'll do some more questions. And again, we have to cut this off at 11:30, but these individuals will be available throughout the day and other days for individual interviews. This mission is very transparent. You will get to interview folks and other scientists on the mission. So go ahead, Joe.
David Schuckman, BBC News. Just one more follow-up on the question of the debris and the risks to the spacecraft. Do you expect dust and small particles to become denser the closer you get to the center of the system?
Absolutely, yes. So let's talk about how that occurs. You know, the Pluto system is orbiting in the Kuiper Belt, which is more or less a shooting gallery with lots of small primordial comets and other things much smaller than Pluto. And when those things strike the small satellites, of course they make a crater, and all the material that's excavated from the crater actually leaves the satellite and goes into orbit around Pluto. When you actually model that, the smallest satellites, Nix, Hydra, Styx, and Kerberos, don't have enough gravity to hold on to the ejecta from their own craters. The velocity of that ejecta is too low to escape the Pluto system in many instances, so it ends up in orbit. Now, it doesn't just build up and build up, because there are processes that we call loss processes that actually also remove that debris. So there's a balance between production and loss, and all the models that we have show that the highest density of debris is in the region of the small satellites. Interior to that, Charon's gravity, which is powerful, clears the zone. And beyond Hydra, we don't have any more satellites, so we don't have any more sources of debris. So we think that the most dangerous place, although it's not very dangerous, I want to go back to my earlier statement, the models are showing us about a 1 in 10,000 probability of loss of mission. But the most dangerous place is as we cross the satellite plane. That's Pluto's equatorial plane as well. And so that's kind of a moment of truth for the spacecraft at this low level of concern. And then some hours later tomorrow, we'll hear back from the bird and how it did.
We're going to go to this gentleman, then we're going to go to Frank, Tariq, and then we're going to take a couple of social media questions and come back for a few last questions before we wrap up. Yes, sir.
This question is for Alan. Bobby Russell, Quest for Stars. First off, let me commend you for having student-built research on board. And along the same lines as the last question, in regards to dust, when will we start getting data back from the student dust collector experiment?
Yeah, well, thank you. We're very proud to be carrying the first student-built instrument ever placed on a planetary spacecraft. And I should say, that's now become pretty common, and we're very happy to have helped unlock that for students. But the way that the SDC, the Student Dust Counter, works is a little different from the other instruments. All the other instruments report their results out onto the spacecraft bus, and then they're stored in the solid-state recorder that the spacecraft has, the main memory. SDC is different in that it caches its own data in its own memory, and it's only dumped later on command. So SDC has been reporting data all the way across the solar system, and we've dumped that memory many times, and we've actually got a trace of the dust distribution inferred from the impactor distribution all the way from 1 AU now out into the Kuiper Belt at 33 AU. And by the way, this is a record distance. The previous record for a dust impact detector was on the Pioneer probes, and those instruments, because of their design, actually weren't able to operate beyond 18 astronomical units. So we're pioneering something new out here this far. We're very interested in impacts in the region around Pluto, and we were monitoring that in the inner fringes of the Kuiper Belt late last year and very early this year. However, when we actually operate at Pluto, the Student Dust Counter hears all the thruster firings on the spacecraft from all those turns that Kathy was showing you in the animation. So we have to change the squelch level on the instrument so that we quiet down the racket from the thrusters and only hear the largest events. We've done that, and we're going to continue to record data that way until July 31st or maybe July 30th. And then we'll go back to the more sensitive mode because we will be spinning again and not using the thrusters. And then in August, that data gets dumped. I believe it's August 3rd, but we can get back to you on that.
Frank?
Frank Mooring with Aviation Week for Alan or Kathy. Yesterday, Alice Bowman told us that the engineering download tomorrow will come because there's another observation that sort of points the antenna this way. It's called the plasma roll, I think. Could you describe that observation and how it happens to be pointing the antenna this way?
Sure. The plasma roll is an observation that's designed to look at the interaction between the solar wind and the plasma environment around Pluto and Pluto's extended atmosphere. And so we point the antenna towards the Earth, and then we roll the spacecraft around that axis so that we can sample the plasma environment around in many different directions. And so that's the preferred direction for the plasma suite to make that kind of comprehensive look at the system. And so we'll then be able to transmit back to the Earth because the antenna is pointing in that direction.
Thank you very much. Tarek Malik with Space.com. And my question, I think, is for Alan. You said earlier that the data that you're getting back from New Horizons is a gift for all of mankind now. Today, we don't know what it looks like close up. Tomorrow, eventually we will. And it's been 9.5 years plus in transit, I think a decade more in development. And I'm just wondering, Alan, kind of what you and the team is feeling like now, knowing that by the end of tomorrow, a lot of your questions are going to be answered, and maybe you'll have more questions to ask on the way out. Thanks.
You think? Yeah. There's a tremendous energy in the science team and in the operations team right now. This is a little different mission than a lot of missions flown recently because we've had to fly for such a long period of time to reach the primary target, 9.5 years. Now that's not a record. Rosetta, for example, traveled farther. And I'm actually a participant in the Rosetta mission. One of the instruments on board is my responsibility. So I can tell you firsthand, on Rosetta, we had a whole series of flybys along the way. We had 3 Earth gravity assists. We had 1 Mars gravity assist. We collected data at all 4 of those, and we had 2 asteroid flybys for science. So it didn't seem like we were on this interminable road trip. But New Horizons is different. 13 months after we launched, we were at Jupiter. We had a very active science encounter in February of 2007. We did the gravity assist right on the numbers. And then off across this giant ocean of space to get out to the Kuiper Belt. 8 years in cruise, and we didn't pass anything along the way. And in fact, when we passed the orbits of Uranus and Neptune, they were farther from us around their orbits than they were from the sun. So it always seemed that the encounter was very far away. And now that we're in it, people talk a lot, and you'll have an opportunity to meet many members of the team the next couple days, but people talk a lot about how surreal it is that we're actually here, that we've reached the target. It's been something that's been in our future for so long, and Kathy can comment, I think Glenn should comment on it, because it's not just the science team, it's all of us that are having this experience. For myself, I said it feels like you've been walking on an escalator for almost a decade, and then you step onto a supersonic transport. And that's the pace of the flyby. So it's pretty impressive, and it's a little bit surreal, but the energy level is just electric. What?
Yeah, so I've been saying for some weeks that until we start actually seeing Pluto resolve in the LORRI instrument, it was like, yeah, we're going to get there, we're going to get there. And then all of a sudden, it's like the freight train's coming down the track, and you're seeing this light coming at you, and you know it's not going to stop. You can't slow it down. It's going to get there. And of course, the light is Pluto, and we're all excited.
Okay, let's switch up here and go to social media. Chris Blair, I'm hearing there is a lot of conversation, a lot of buzz. What's out there in the social media world?
Yes, thank you, sir. We appreciate it. Christopher Blair from NASA's Marshall Space Flight Center. And the first question from one of our wonderful global users comes from @PR Alford and @John Wise. I'm mixing 2 together. Question is, earlier we heard about the spinning of New Horizons to beam back data to Earth. Does the spacecraft use gyroscopes or fuel to spin? And if it's fuel, did that impact mission longevity?
So once the only propellant we use is to spin it up to 5 RPM, and then it acts just like a top, pointed at whatever it's pointed at, and we spin it up and point it to Earth, strangely. But once you've done that, it takes no more propellant. It can do that for years and years without using any more propellant. We use onboard systems, including gyros and star trackers, to determine its orientation, but once it's spinning, you can leave it there for a very long time.
I'll add that the actual control of the spacecraft is not done with gyroscopes. It's done with thrusters.
So Chris, let's take 2 more and then we'll come back to the media here.
Excellent, thank you. This is from Jack Crane. Question was, we've seen lots of great black and white images, and so I'm sure you can guess where this is going. When can we expect to see some color images?
You want to take it?
Sure. You can expect to see some color images tomorrow. So we'll have new color down soon, and so we'll be looking at it today or tomorrow and the next day.
And if I can add to that one also, there are a couple of reasons that you see the black and white a lot more. One reason is that the black and white camera called LORRI has much longer focal length, so much higher magnification. So it's been producing the more interesting scientific products because it simply gives us better resolution on the target. But there's another reason as well. When we take color data, the way that we do it is that we actually have 4 color cameras, each with a given filter over them, and we pass them over the target. And then we have to downlink that data. Instead of sending down 1 image, we have to send back all 4. So, and they're actually individually bigger. They have more pixels, therefore more bits than the color camera format. So it's a lot more expensive to send that data down, not in terms of money or fuel, but it takes more transmit time at our fixed bit rates to get color imagery to the ground. So that, combined with the higher resolution, is the reason we've been biasing so much towards the panchromatic imagery from LORRI. But you'll be seeing color products and then eventually spectroscopy products in spades over the coming days and the coming weeks and months as we ship all this data back that's gathered, about 100 times what we can transmit back this week.
Okay, before we take the last question from social media, you can raise your hand high so I can get to you. I know some of you have been raising it a long time, so go ahead, Chris, one more.
Thank you, appreciate it. Once again, following back up, wanted to mention that we're going to be monitoring these news accounts for social media all week long, and so if you don't get your question answered today, we'll get a chance to follow them up. After the closest approach to Pluto, this question is from @KJZing. What are the possibilities of getting new images of the dark regions of Pluto?
Well, I'll take a crack at that. Kathy may want to add to it. After we pass Pluto, we'll be looking at the night side. You know, we're on the sunlit side now, but once we go around the other end, we're only seeing a thin crescent of the planet. And if it's helpful, we can put some graphics up and make them available so that people can more easily picture this. And certainly in the simulations like Eyes on the Solar System, you can see that. So those dark regions are going to be hard to observe because we're looking in this particular geometry as we back away from the planet. You only see a sliver of them at any one time. There's one more trick that we can use, and we've planned for it, and that is that we can image Pluto in the light of its moon Charon shortly after we make the closest approach, so that we can look at the effects of the colder conditions on the night side to see, for example, if there's evidence of snows or deposition of frosts on the surface. But for the most part, the data that we obtain to really unravel what's going on in those dark equatorial regions is going to be the data that we collect in the next little less than 20 hours. Spectroscopy for composition, high-resolution imaging, color imaging, measurements at a series of different angles, some thermal measurements, and other data sets, including the ultraviolet that I spoke about earlier.
If I could just add one thing to that. So one thing to know is that all of this data is on the spacecraft, and we've identified selected high priority science data for playback. And so it's going to be months. It'll be up to almost 16 months for us to get all the data down. So you're going to be seeing new images months from now that you're not seeing this week, because this week our priority is looking at Pluto with the instruments, and we'll play back the data when we don't have science data to take.
Stephen Young with Astronomy Now magazine for Alan Stern. When tomorrow can we really celebrate? When will you celebrate? Obviously 8:53 is the closest approach, but that's Earth receive time, so it's not, it actually already will have happened. And then later in the evening, when we get the signal, will that really be the moment that you will be celebrating?
Yeah, there are two times to celebrate tomorrow. One is a little bit before 7:50 in the morning. At that time, the spacecraft will be at closest approach. We will be 3 billion miles from New Horizons, but connected in time, and that is the time that we will celebrate as this historic moment where we can say we have made a flyby of Pluto, and we're still conducting the exploration, but we've made closest approach, and I hope you'll be here for that. Then, because the spacecraft is incommunicado, doing its work, we won't hear from it until shortly before 9 p.m. Eastern Time tomorrow. And that's going to be a very highly anticipated event because it's sort of putting the cherry on top. We know that this spacecraft can operate on its own. It's done this for most of the last 9 years. And 21 or 24-hour blackout is the way we've operated all the time. But now that we're going through the Pluto system, there is that element of exploration, and there's that small element of danger. So I think we're all going to breathe the final sigh of relief at 9 p.m., and that's when we can really call it a successful flyby. So 2 events and 2 chances to celebrate.
Okay. Let's do Bill. We'll come to you. I believe you've been raising your hand, and then we're going to wrap up with these 2.
Bill Harwood, CBS, for Alan or maybe John Grunsfeld, either or maybe both. What is it about Pluto, though, that's captured everyone's imagination? I mean, this is a small body compared to everywhere else we've been in the solar system, planet-wise. What is it about Pluto? It seems to have really sparked everyone's imagination and interest.
Well, I think if you look more broadly at what we're doing in solar system exploration, you know, we have the Dawn spacecraft around Ceres. Ceres being a main belt minor planet has created enormous excitement. And this, again, is another mission that's been going for a very long time. It went from Vesta to Ceres. We have Curiosity on Mars that's still roving. We have Juno on its way to Jupiter. I think Pluto is kind of a capstone of our solar system exploration and also opening up this new realm. But it's also, you know, just that, you know, for Alan, myself, the rest of us on stage here, Dwayne, you know, Pluto's a member of our solar system and the last unexplored territory. And I know Alan is very eloquent about this. You know, we're opening up new ground. I think from the science perspective, we're entering this whole new realm of the solar system. What's really exciting about Pluto, Charon, the whole system, is that already, from still quite a distance out and 20 hours and 31 minutes away, we're seeing that Pluto really is a complex world, unlike, I think, what anybody imagined. Alan?
Well, I think John put that very well. But I'll tell you, of course, being the principal investigator of a mission like this, I've had a lot of chances to give talks in the public and have people, you know, come up afterwards and tell me why they're interested, and people like to do that. And we've been on this project for 15 years, and what I found is that there's no single reason. There are a whole series of different things that excite different people about it. One part of it is it's kind of unfinished business. It's the last check mark in the initial reconnaissance of the solar system in many people's books. Some people say, you know, when I looked in that first astronomy book that I ever had, it's the one with all the question marks. It was the most mysterious. Other people, you know, it's the farthest frontier. For some people, and particularly I notice this with children, because Pluto's more diminutive and they're more diminutive, there's an association there. And there's the unknown, and there's the scientific accomplishment of exploring this whole new kind of planet, the 3rd zone of the solar system. And I think all those things weave together very well. And Pluto is, in a way, sort of become a brand. And we're seeing a sort of viral response in the public. And the other thing I think that shows us, beyond Pluto, is that there's a hunger and a thirst for exploration. People love this first-time exploration. They like, just like we do in science, turning little dots, you know, little points of light into planets that we can transform our knowledge. We can write the textbook from scratch. And I think all those things go together and resonate very well with one another. And that's what produces this great interest that your presence here, is evidence of. And we are really looking forward on New Horizons to being able to tell that story of exploration with you and to show you the behind the scenes where we can and to show you how the science actually gets done, not just the data products, but with time to show you how we actually transform simple things like a radius into much better understandings of the origin of the solar system, how binary planets get made, how atmospheres work, all those things, because that's a teaching moment. When I was a little kid, it was the Apollo program, and it excited so many kids to want to go into tech careers, and most of them didn't end up in the space realm at all. They ended up, in various forms of engineering, and a lot of them made the internet revolution. They made the computer revolution of the 80s and 90s, and personally, I attribute a lot of that to the excitement that I saw in my age cohort, due to Apollo. If we can be a small part of making kids excited about STEM education and careers in science and engineering through New Horizons, that may be our greatest gift.
Okay, 3 questions and 1 only, and then we're going to have to wrap up. Go ahead.
Laurel Kornfeld, Spaceflight Insider. Regarding the new information about Pluto being less dense than previously thought, does that support the possibility of is that evidence supporting the possibility of an subsurface ocean? And the other thing is, as far as you're saying Charon has no atmosphere, has the team ruled out the possibility of a shared atmosphere between Pluto and Charon?
You want to take the first one, I'll take the second one?
Sure. So the change in the density, the change in the radius, that from what we understood before to what we know now, is really just very new news. And so we need to take a look at that. We're going to be getting even more imagery down with Pluto filling the field of view even larger. That'll probably help constrain that error bar some more as well. And so it's too early to say what the implications are for that new radius right now.
So I'll speak to the question about Charon's atmosphere. I think one of the coolest things about exploring the Pluto system is looking for whether Pluto's atmosphere streams off to create a secondary atmosphere around Charon, the way that a lot of binary stars share their atmospheres. We've never seen anything like that in a planetary system before, and we're going to test it tomorrow. In fact, we're going to put it to bed, more or less, because the ALICE ultraviolet spectrometer is going to do the same experiment for Charon that it does for Pluto. It's going to watch the sun go behind the planet and come back out the other side. And what we'll be looking for is the diminution of sunlight before it hits the hard deck due to molecular absorptions in that atmosphere. And if we see that, then we'll know that Charon has an atmosphere, and we have a tremendously sensitive instrument. It can measure pressures down to the nanobar level. That's a billionth of the pressure in this room, and it's 1,000 times, in fact, it's 10,000 times lower than the pressure at the base of Pluto's atmosphere. So that data is going to be very valuable, and it's not only going to tell us yes or no there's an atmosphere, but it will tell us what molecules are in the atmosphere and how they vary with altitude. And by connecting that to the Pluto occultation, we'll have a pretty good handle on whether Charon's atmosphere is native to Charon or whether it's a shared atmosphere streaming off of Pluto. But we won't know any of that in the coming days. That's going to take a while before those data sets get back to the ground.
Alan Boyle with NBC News for Alan Stern. You mentioned the confirmation of the polar cap. Is there anything at all that can be said about those dark equatorial regions at this point? Some people have talked about ice volcanoes or ice geysers. Any evidence for or against that, or any other of these hypotheses that were put forward over the past few months?
Well, as you can imagine, we're very interested in those kind of questions. And so the geology and geophysics team is all over that. They're stretching those images, and they're using other more advanced techniques to look inside those dark regions. And the thing is, for now, for today, we have relatively poor resolution compared to what's going to be in our hands. And we don't yet have good color data sets on them yet. That's coming in the next 24 hours. And some of that's going to come to the ground this week. And we're going to get compositional spectroscopy. I think the only thing that I want to add in answer to your question about the data that we have is that these first compositional measurements that we were able to get where we could resolve different regions on the surface of Pluto show us that the polar regions are compositionally very different from the dark regions. For example, the methane absorption bands are much weaker there in the dark regions. Exactly what they're made of is TBD. We're going to have to work on that for a while because there are a variety of candidate materials, and we need to get better data to be straight about it. Because in the darker regions, you naturally get lower signal to noise because they just don't reflect as much light. So stay tuned.
A quick one question, and Dr. Grunsfeld has some closing remarks, and then I'm going to wrap up.
Kelly Beatty from Sky and Telescope for Kathy or Alan. I'm sorry, you had me at nitrogen 5 days ago. Can you put a number, a distance upstream for where that is? And does this mean that there's more nitrogen in the atmosphere? It's being pushed out faster? What are the range of possible candidate mechanisms?
Yeah. So 5 days out, it was day of year 190 that the nitrogen, the molecular nitrogen, was detected by Pepsi. This is ionized nitrogen that's been out in the solar wind and is ionized either by electron impacts from the solar wind or by solar ultraviolet. And Pepsi is very sensitive to that, but our models, we had anticipated detecting things coming off the atmosphere in the last 24, maybe 36 or 48 hours. So this is about twice as far out, about 5 days before closest approach. We're going about 750,000 miles each day, a little over 1 million kilometers, about 1.2 million kilometers a day. So if you multiply by 5, that's about 6 million kilometers or something, roughly 3.5 million miles out. What that tells us is that, as I said earlier, either the source is stronger, the escape rates are stronger, or the conversion from neutrals that are escaping to this ionized species is more efficient, or there's some sort of mechanism that's concentrating the ionized nitrogens along the flight path in some way, not because it knows that we're there, of course. But at Jupiter, as we exited the system, we found that the planet's magnetosphere was very inhomogeneous. This was actually a very important discovery made by New Horizons as it made its transect down the magnetotail of Jupiter. And we found we went in and out of regions of enhanced concentration of sulfur and oxygen, which had been derived from Jupiter's volcanic moon Io. Whether something like that is being created in the environment near Pluto, but with nitrogen instead of sulfur and oxygen, is a great question, but we don't have the answer yet. And it may take a long time until we can piece all of that together. Okay, John.
Well, I think you can tell from Kathy and Glenn and Alan that this is just going to be an incredible experience for all of us, and I'm really thrilled that you're all here to follow it. 20 hours, 22 minutes, 0 seconds. We're about 625,000 miles from Pluto right now. I won't read down the numbers as they go, but it's going to be a really dynamic next 24 hours plus, and it's just really emblematic of that science at NASA never sleeps, and I don't think you will either for the next couple of days, but it will be exciting, and I want to thank all of you for being here.
Okay, real quick, for folks who want interviews, one-on-ones, for folks here in the center, check the newsroom. Dr. Grunsfeld, Dr. Jim Green, head of planetary, will be available throughout the day. And for the folks viewing this, 240-228-8532, call in. We set up interviews. The stage is set for the July 14th Pluto flyby of NASA's New Horizons spacecraft. Go to www.nasa.gov, New Horizons, and tomorrow, ladies and gentlemen, live, starting at 7:30 a.m. Eastern, the countdown program to New Horizons entering the Pluto system, followed at 8 a.m. Eastern by a news briefing. And I believe we're going to have some live coverage of the Mission Operations Center. Thank you for joining us. See you tomorrow.
Didn't see that.
Coming to the mark tonight for that going over the hill.